So this session is about Kafka, Apache Kafka and Spark streaming. So how many of you have used Spark and streaming and Kafka together? Everybody used Kafka only? So I guess Kafka is normally used when you have large scalability requirements and middleware. Are you guys familiar with middleware? No, if you are not familiar with Kafka, middleware, what is message or in middleware, right? JMS and all that, TIPCO. Right? So Kafka is like another new middleware from Apache, but it is used for different use cases, very high amount of scalability requirements. So I am basically the architect in open source group and big data in Wipro. We have an open source group in Wipro where we handle a lot of technologies. So my job is to research on the latest technologies, find the business application of these technologies, and prove them. Like we do benchmarking for big data, how much scale can it handle, all that. Initially we look at Kafka, and then we look at the Spark streaming. So yeah, when I suggested this to Madhu, right, he told me that a lot of people have actually asked for this. So I was just thinking, like, after attending last session, I'll just give a talk on this, because it's basically this talk is about the ecosystem of Spark, right? Not about the core Spark. So we assume that you know some of the Spark already, RDD and DAG and everything. So we'll start with the Kafka concepts, and then we'll see how to use Kafka, and then when to use. There are no specific slides on when to use, but it will be a iteration. You can talk about when your questions, and we'll discuss that. Then Spark streaming is how to use Spark streaming for processing your real-time data. When you have real-time data, and then we'll also talk about how Kafka works with Spark. And then the internals of Spark streaming, which has lots of internal concepts, batches, time windows, reliability in Spark streaming, all that. Kafka. We'll start with Kafka. So basically, Kafka is basically another message-oriented middleware, where you want to handle millions or billions of messages per day. So, and then it has only 4 concepts. It has brokers, topics, producers, and consumers. If you know what is messaging. So once you understand this, then you can start programming in Kafka. So although Kafka is good for the business, that means it can handle more scale. You can scale your business well. It is not easy for programmers or developers when you're starting with Kafka, because its architecture is a little complex, and then it is not, even if you know messaging, its architecture and its usage are slightly different if you look at from a programming level, programming Kafka. So that is a thing. So you have to understand the concept first. So let's look at brokers. So Kafka broker receives message of producers. So that is like normal thing. So somebody sends message and broker receives it, and then you have what does the broker do? It puts it into log files. So Kafka is a persistence-based mechanism. So like in normal JMS, you can say you put it only in memory, put it in hard disk. But Kafka persistence always goes to your file system, and it has many log files where each of your messages are saved. And then when a consumer says the third point, give me this message, the broker has to fetch that message and give it. That is the third point. Then other part of Kafka is the zookeeper part. So zookeeper is an implicit part of Kafka. You want to coordinate zookeeper does lots of critical work, like coordination, state management, cluster. So these are like complex terms. Cluster configuration management, that we will see when we are looking at the other topics. All aspects of Kafka requires zookeeper. The consumers, producers, and brokers need to know about zookeeper, because everything is in a state. Basically, the state of anything is maintained in zookeeper. So topics. So here is where the main concept comes. So those who worked in programming, you know about topics and queues, right? I don't know. If somebody wants to explain what is topic versus queue, somebody's done a message programming.
Basically, a subscription mechanism wherein you can actually choose to subscribe to a topic. A topic is nothing but a logical section wherein messages of that logical hierarchy will be delivered.
Yeah, right. Then queue as opposed to topic.
One-to-one and one-to-one.
Yeah, right. So topic is normally you send to a topic and anybody who subscribes, like you said, can see it. So it's like one-to-many. Queue is one-to-one. You send to a queue, and there can only be one consumer. That is the difference. So from the sender side, it's same, but the receiver side, it's either many receivers in a topic or a single receiver, consumer in a queue. So in Kafka, there is only one concept called the topic. There is no queue concept. The same concept, the same idea, you can manipulate differently to make it a queue or a topic. So that is the first complexity in Kafka, right? To understand. So how you do that is using consumers. So you say, okay, I have this topic. There's no, and then I want to send message to this topic. So the sender sends message. Then you create a consumer. If you want to make sure that only one consumer receives it. In topic, normally a lot of all the consumers who are listening to the topic will get it, right? But you are saying you want to use it like a queue. Only one consumer should receive it. So how you say you create a consumer group. It's a logical definition. You group all your consumers in one group, and then consumers who are part of that group, each consumer in that group will get only one message. Will not. It's a unique thing. So one consumer will not, two consumers will not read the same message, unlike in topic. So that is the initial thing. Initially, I was thinking, hey, when I started Kafka, hey, Kafka doesn't support queues. No, I can't use it. Everybody seemed to be using it, but then you read the documentation. It actually shows. So Kafka has got some good documents, but you need to go through it and spend reading it multiple times to actually understand the detailed concept. So I put some references again for those who are new to Kafka. So consumer groups is another thing. This is you can have groups of consumers. So you can have consumer group 1 for topic 1, another consumer group 2 for topic 2. So where you can actually have consumer in consumer group 1 and another consumer in consumer group 2 can actually read the same message. You want to use it like a topic. But then it also gives you scalability and reliability, because this consumer goes down, you can still have somebody who will read it. And then reliability is also there. You don't lose the message or lose your processing flow. Data flow is maintained. So if you are clustering Kafka brokers, consumer groups are used. Another concept is consumer offset. So when you read from TIBCO queue or IBM SQL message queue, you always read the latest message, right? It's like So you cannot say, give me the third last message from the queue, right? Or second last message. Or I have some 100 messages, give me the the oldest message. You always get the latest message. Latest message in the queue. So it's like first in, first out. In Kafka, you can actually say, give me the 56th message. Or I can say 56 to 71st message. Give me all those messages. That API allows that. So which is good. Sometimes you want to read batches because you process everything together, like in Spark streaming and all, or SQL kind of coding. You have the same functionality. You perform the same function, or like MapReduce. You reduce by key. You perform the same function on 10 items, or maybe 1,000 items at the time. So that means you get one item at a time. Then it's not a scalable solution. You read 10 items at a time. So that option is there. That is the offset concept. The other concept in Kafka is partitions. So partition means, So when you send a message to a topic, right, you're thinking it's one thing, but it's actually internally, physically, it's like logical versus physical. Physically, it's actually many items. Basically, each topic can be partitioned to partition 1 to partition 2, partition 3, n number of partitions. And that is the core scalability feature of Kafka. So each partition is mapped to a log file. So you write to different partitions. When a producer writes to different partitions, and consumers can read in parallel. So when you have multiple consumers, if you read in sequence, then parallelism is lost. You can have the partition, you can delete in parallel. So I'll just show you a diagram which actually show this a little easier. This is a architecture, this is some GitHub project somebody has created. So you can see that producers, no, you actually write. You can write to, when the producer writes, you have to decide what to you want to write to. You just don't write to a broker. You write to partition 1 or partition 2. Then consumers automatically load balance. So Kafka engine decides which consumer reads from where. So that is the thing. So this all partitions are partition 1, partition 2, partition 3. Parts are part of the same topic. So somebody has created one topic, but internally it is 3 partitions. The producer A decides, okay, I will write to A and B. Producer B decides, okay, I will write only to one partition. When you write, you can also decide, okay, I will not give the partition number. Then Kafka will randomly assign to some partition. And within that, like I said, you can consumer can say, okay, give me message number 1 or message number 0, not the latest one. So ideally, when you read, you will get from latest one message only. If it's 1 on partition 1 and 2 in partition 2 and 1 like that. So I've just taken a shortcut instead of creating my own diagram. This reference is there in the other point is the maintains one log for each partition. Say like if you in a database log, right, when you write to a database or read from a database, for reliability it writes to a log file. Like that, Kafka is based on same architecture like a database. So it creates lots of log files, and for your topics it creates these log files, and the consumers can read from in parallel from these log files. So hope that concept of topics and partitions is clear.
So to send a message to a particular partition.
Yeah.
So
So basically consumers and producers need to know the zookeeper instance, the URL and port number, and the broker instance. So earlier there was this broker slide, no? So you define a Kafka cluster in a set of instances. You start many Kafka brokers. One of them will be elected as a leader internally. There will be election. So the producer sends to a Kafka leader. So there are 3 brokers. The leader will get the messages. So the broker URL and the zookeeper URL producer needs. So what are the?
but we can't control which partition.
Yeah, partition number is an attribute when you send it. So and it's optional thing. So when you send a message to Kafka, there's a partition number which you don't have to give, and then the message, set of messages. You can send one message or a set of messages.
We can write our own custom partitioner over there.
Yeah, so
And on that basis, that can be divided to each part.
yeah. So if you want a complex logic to decide which partition it goes to, you can write your own custom partitioner, like you said, and then that will decide instead of you each time you send it, that will decide, or you can delegate that work to Kafka.
I think you might cover this, you might cover this later. What's the level of abstraction? Do the consumers actually operate at the log level, or is there an interface, an easy interface provided?
Yeah, correct. Yeah, we'll cover that later. Yeah, we've not reached the consumer. This next slide. Any other questions on producer or broker?
Like, how much back we can go? Like we can go back to 0. How? So is that
Yeah, correct. So no, I have not covered that separately. So basically, that's another thing. When you in normal messaging middleware, when you read it, it's gone. Broker does not have it anymore. It will delete it. As soon as somebody reads that message, it's gone. But in Kafka, it can stay infinitely. As obviously there's a limit to hard disk size or something, and then it. So Kafka does not throw away, delete your message as soon as you read it. What happens is it's configurable time. So default is 1 week. So I think 7 days. So any message you put in Kafka will stay on disk for 7 days. Then it will delete it. So you can make it okay, delete after every 1 hour or something. So that is the limit. So if you say give me the last 1 million message ago and it's not there on your disk, then you cannot get it. It will be what is available. It's not deleted. Till then you can get those messages.
Is there any concept for acknowledgement?
Yeah, that is there. So that is in the consumer side. So when consumers read, you acknowledge. Producer acknowledgement, I think it's default. I did not try that. Whether you can, because basically when you send, right, you want an acknowledgement. I think its default is there. I don't know if you can disable that acknowledgement. Because ideally when you send, you will get an exception if your send failed. So in consumer side, the acknowledgement is more important because you want to avoid duplication of reading and all that. So one thing about the consumer architecture of Kafka is that why it is much more scalable than other. Like when you're deciding, okay, why Kafka? Why don't we use Apache? Has a lot of other products like ActiveMQ, Synapse, even in Apache itself, messaging engine. Then there's this new thing called NiFi, which I was looking at, which has much more features, highly scalable, and you can actually track the messages across while flowing around. If you look at the open source community, there are lots of open source messaging engine. The Kafka architecture is very scalable because it doesn't do a lot of work that normal messaging engine does. Tracking who read what, how much is read. All that is given to consumers. So consumers load increases. So in many times when your broker is out of memory, it's because some consumer is slow, some consumer. So basically that's because your normal messaging engines take care of a lot of metadata and coordination work themselves. So here Kafka has delegated a lot of work to Zookeeper, a lot of work to consumers, and some work to even producers, because you decide which partition you send to and all that. So consumers, as it says, you consume messages from Kafka, and there are two levels of APIs that Kafka provides, abstractions like you were asking, right? The simple API and the high level API. So the simple API is not actually simple, it's the complex for programmers. Maybe it's simple for Kafka. Normally when you read, right, you read one by one, you read messages one by one. Each consumer reads messages one by one. Then what happens is, in Kafka, you have to remember which was the last offset that you read, so that you can read the next one. So you don't say, give me the next one. You actually say, give me this number. Every time a consumer reads, you have to say, give me this number. This is the number I want. Kafka will not remember what you read. So that is the advantage for Kafka for scalability, but you have to take care of it. So that is how you use simple API. If you use simple API, you will have a lot of control, but you have to remember all the different what you read and acknowledgement, all that. And then, so for that, it's not just interaction with the broker. You have to interact with the Zookeeper also. Zookeeper is where all the offsets are maintained. Offset means partition that you read. So maintained in Zookeeper. So that makes Kafka architecture simple. The broker, because Zookeeper does all the metadata and state management, and even if a consumer is disconnected, right? So you are reading and suddenly you got disconnected. Zookeeper finds out the timer and everything is in Zookeeper. This consumer is disconnected, or let somebody else read from this partition. Is initiated by Zookeeper, because each consumer can only read from one partition. So that is there. So once a consumer dies, somebody else can read from the other partition. So the high level API is a simpler thing for us, like for developers. It actually, it's a little more bigger library, but you don't have to keep track of all these internal things of the broker. It will remember what is offset and all that. You can always say, give me the next set automatically, and that offset is maintained in Zookeeper.
So the messages, do they go through Zookeeper, or it's just a...
Yeah, no, Zookeeper will not go, it's just a coordinator. So each message you producer sends goes to the leader in the cluster. And leader actually, so basically a leader will be putting it in the correct node, which broker which you are reading from. So it doesn't, messages won't go through Zookeeper. All is coordination part, metadata state management.
So on the client side, it becomes two calls. First call you need to Zookeeper to get the metadata, and then
yeah, correct. Not for each message. So Zookeeper connectivity happens only when you initially connect to the broker. So then you read from the broker continuously. So when you initialize, the code will be like, oh, you connect to the Zookeeper, find the leader, even the leader information is in the Zookeeper, and then you connect to the broker. So and subsequent, each message read is actually from the brokers.
Do you have like a demo after this?
No, so actually I have a, no, actually I wanted to do that, but I have not created a demo. But demo is very simple. I will show you a reference to a set of instructions where you can do, and you should do that because if you are starting first time with Kafka, no, you have to try the simple examples. So that's what I will show you. I am not running it. I will just show you the command lines which.
One more thing is that if I have a Hadoop cluster, right, it's
Yeah.
got like 5 or 6 nodes, data nodes for example.
Yeah.
Can I run those partitions one per data node to have the redundancy, or what is your recommendation? How does this architecture fit into a Hadoop cluster, or do I need to have separate Kafka cluster for this?
So see, when you say Kafka cluster, so Kafka cluster and Hadoop are independent. So you can actually share the hardware.
Yes,
with this.
that is what I'm saying. So can I do that for all those partitions that you set for a topic, right? I mean, are they better off being on separate machine, individual machines?
So if you are, see, when you read, you send messages from somewhere to Kafka, and then you want to copy to Hadoop cluster?
Yes, copy to Hadoop. I just want to use that hardware. Basically, I have a hardware which is actually running Hadoop, right?
Yeah.
How do I optimize
So you can
that?
install Kafka on the same hardware. There's no
Yeah,
problem.
okay. And how do I optimize it? So should I use the partitions in separate nodes?
So yeah, so there is a confusion about your Hadoop partitions and Kafka partitions. So and these partitions in Kafka partition, it is very fine grained micro architecture. Within your topic, you have 10 topics, you can have 30 partitions. You got it, no? Each topic you partitioned into 3 parts.
Yes, but can the partitions need to be in the same machine, or can I split it across a set of machines?
Yeah, so there are a lot of configuration options which I have not shown here. It's like big property file, where you can configure what to store where. So you can have your partitions, by default obviously you should have it on the local disk where your broker is. Or you can have it on a highly reliable SAN where you are mapped. So basically you are not taking a risk of your hard disk failures. But Hadoop, there is no direct mapping that you put this, you cannot put it on a SDFS because Kafka API does not support SDFS. So you have to put it on a file system.
No, typically production systems, what you see a single server running the entire Kafka.
No. You have a cluster of brokers.
Cluster of brokers.
Yeah. And you can share the hardware, but if you have enough capacity. Because if you are sharing your SDFS and Kafka, then both of them use hard disk space, no?
Correct.
And of course, your memory bus and CPU and everything is used. So if you have enough hardware, then you should think of sharing it. So SDFS primarily it's an IO bound thing, and so Kafka will also be IO bound. So that is the critical path. Even if so you should calculate, not just your hard disk available space, because memory buses will also be shared while writing to the disk. So not the, yeah. So fault tolerance is using the brokers. No, you can have a cluster of brokers, and each broker will have a leader. So and then you can say the replication factor. So when you write, when you create a topic, so topic I shown one, right? So that partition is not a replication factor because you write to one partition only. Those partitions can be copied to another broker. So when you create a topic, you say replication factor, just like a SDFS you have used, right? Replication factor is 2 or 3 or 10. So each replication factor will reduce your scalability because you have to get acknowledgement of that right. You have to replicate everywhere. That's something.
So here broker is writing to the local disk. Who does the replication?
So you don't have to. The broker engine will take care of. There is no separate replicator. Part of the broker logic will take care of the replication.
Like in the case of SDFS, data node is writing, it will again ask another data.
Yeah. So basically, the other broker will have the same logic here. So you write to that, and then acknowledgement comes. Then this broker will be sure that it is returned to other. So basically, it is at the topic level. So one topic can have one replication factor of 2, other can have 5. So now default is 3. Replication factor is 3.
Let's say the consumer is reading from a partition and that is down. So
Yeah.
what has to be changed for us to automatically seamlessly connect to the other part of the replication?
Yeah. So that is broker is down, right? So when broker is down, if that is leader, then some new leader will automatically be elected. So that is zookeeper's responsibility. Zookeepers take care of all the consumers and producers. No, it has all the metadata of all the consumers and it pings. So sometimes your one broker is slow. So and the other point is, so which also makes it a critical point. Like I said, no, sometimes your zookeeper will be like there is a latency. It will ping for the heartbeats for all these items. And if it doesn't get that response within that time, it will assume that broker is down. So sometimes broker may not be down, there is a network latency. So you have to do with trial and error, you have to configure your zookeeper that heartbeat response time. So and for everything, not just brokers, clients and your clients which read the messages, producer which send messages.
Okay, so this logic goes into the client because if broker is down, now you said that we connect to client connects to the zookeeper only at any.
Yeah, so how it's solved is, I didn't answer the complete question. So when a client connects, right, you say you don't connect to one broker. So you have 3 brokers in your cluster. You give a list of brokers, the IP address and port number. So automatically, if you give only one broker, then it's dead. Broker is dead, client is also dead. It will not write somewhere else. But if you give a broker list, it's a like hash map kind of thing. You list of brokers, it will connect. It will try the next broker. If one is not responding automatically. So that is taken care of by the Kafka architecture. Client will have and supports a list of brokers. That is a.
What about the transformation logic? Where is the transformation logic?
Yeah, so messaging engine normally you don't transform it. You just write, read. Yeah, that is how the messaging engine works. It is just like a resistance, in the electric circuit. Just matching the one may be too fast, the other is too slow. Then this will make the speed normalized.
So let's say initially when the client connected there were 3 brokers. So over time what's happening is the scale is scaling up more and more.
Yeah.
I'm assuming there is more brokers. It's scaling very large. Each of these consumer or the client has to reconnect with the brokers.
Yeah, so that I have not tried out. So what I've seen with other clusters like this is the zookeeper, right? So when you add a new broker, right? Zookeeper would get updated. But I have not tried because the client, once you started, that context class is fixed. So you can't add dynamically a new broker into client's context. So I have not checked. Basically, there may be some other API. Basically, if the client is using the zookeeper as a central point for all broker list, I think there is a API to get the latest broker list or something like that.
Can I call the zookeeper, get the thing?
Yeah, that you can do. So zookeeper has its own API. So actually, zookeeper is a separate project. You know that, right? So Kafka uses zookeeper's API for getting the metadata. So actually, that example is already there in the later thing, where Spark team have already used the zookeeper API directly. So there are the next section of Spark streaming, right? I'll talk about that.
That is consumer part.
Yeah, consumer.
Producer part.
So producer same problem exists. Yeah, but the API is already there in Zookeeper, so you can write your own API. Like even if I don't know if Kafka provides that API, but consumer API we already know that exists. Like he said, if there are 3 brokers when I started, and all of them did, then or maybe I just increased from 3 to 5. I should be aware of dynamically of all the brokers. Yeah, that since Zookeeper provides API, you can do it yourself. Which, but I don't know if it is part of the default Kafka producer and consumer.
Connect using Zookeeper IP and port. Other system like Database connects with Zookeeper IP and port because there are many nodes. Then Zookeeper takes this information and actually gives actual results. After they have something like where client can only connect with Zookeeper and that sort of thing.
Yeah, so that actually this is deriving from what you are same discussion point. Kafka actually requires a broker list when you connect. You can't just, because since Zookeeper knows all this, you are saying, why don't we just use only Zookeeper, right? Yeah. I don't know if it is a partitioning thing.
You have got the legacy. already has an API.
You can configure
The complexity will be the client.
You can configure it because there is nothing directly connect the Kafka API. From which our position
So what he's asking is like, can I avoid the broker URL at all? No. So whatever I tried, I don't think it is. Yeah. So that one option is like, no, this is all trial thing. Before you create your broker URL list, you get all the broker URLs from Zookeeper, and then you add that to your function. So when you create a connecting API, so there is a connect API in the Kafka consumer. You get all the brokers from Zookeeper and then create that. But then you have to dynamically keep polling it every 1 hour or something. Every 1 hour or something, ask Zookeeper watch which is the latest list, and you can update it. This is all trial logic. This is not the default way that you are supposed to.
So if I understand it right, the list would only change if one of the node fails or we increase the redundancy factor.
Yeah, correct. List would change if node fails. Even the consumers, even consumer information is maintained.
I'll tell you one thing. If you're designing an architecture, right? So what would be your what are the factors you need to consider? Whether you want to use Flume, right, for as a service, or you want to use Kafka. Because essentially both are doing.
Yeah. So that actually that is one of my agenda points. When to use, how to use, kind of thing. We'll just finish this things maybe after this. So Zookeeper provides all the API you want, but not the Kafka default API is not there for all the different combinations you wanted. Like dynamic scaling or increasing the size of your cluster. You want, I think it will be possible to do, but then you have to use the Zookeeper API directly, and then dynamic keep kind of polling the API.
So Kafka doesn't keep your client
the client library.
and the way it is in SPS, right? So this client connects to Zookeeper,
Yeah.
you can know the partition.
I don't know. Basically, the simple API is actually for consumers. Simple API is high level, right? It is not for producers. Producers just one API. So it is not there is no producer API for different. So if at all it gives, it will be only in the simple API. And I think it's a little more abstracted. I think HBase gives very low level details and functionality. So I guess we will go to the next point. Read from offset. Consumers are mapped. So I think we covered all these points. Consumers are. So next is
And if a broker goes down, who takes care of the so another broker will take that. Whoever has that file.
yeah. Basically, if you set replication factor is 3, right? So one broker goes down, other will be there. But then there's no new law will be launched. You will have to basically the remaining 2 will be part of the cluster. So that
doesn't maintain the 3 after.
yeah, correct. 3 will not be there. Then you have to launch a new admin or operations team. You'll have to launch a new one. Then it will join the cluster. Yeah. Basically, there is no cluster manager automatically. See.
So in case of SDFS,
See, even when you start it, right? When you start a Kafka, you manually start the cluster one by one, each node. It's not like Spark, right? You say, okay, 10. You start.
And the fault tolerance is a problem, right? Let's say in the next 5 minutes, every 5 minutes I have replication factor 3. All the 3 brokers are down in like 10 minutes, 15 minutes.
Yeah, correct.
I'm like down.
Yeah, so that is something that you have to basically, there will be third party software which will take care of automatic deployment. Basically, just launching is not just that because that server is down because something hardware went wrong, or maybe just the hardware is not wrong. You can have automatic restarts, like your cron or something, some polling tools which will automatically, or management tools. In the operations team use a lot of management tools to restart servers. If your JVM is down, you can restart it. But it's not part of the core Kafka cluster to maintain the cluster maintenance. It will monitor. So Zookeeper will know that this node is down, but it will not automatically restart.
Is there a management?
No, Kafka doesn't come with a default management console. There are a lot of GitHub projects which does this.
Nothing in Apache.
No, nothing in Apache. So you have command lines tools to create topics and all that, but there's no web-based UI for actually monitoring your Kafka topics and brokers and all that. As part of the default implementation, there are some other smaller projects which does this.
I think we should compare Kafka with other messaging systems. Yes, when other messaging system doesn't even give that Kafka provides.
Yeah.
We see compared with that.
So lot of questions have come, right? Many of the things that you've seen default in other systems are not there in Kafka. Then why would you use Kafka? So that is boils down to this question. What's your name? Arnab, yeah. So why should you use Kafka? So that is the next point before this training. So if you look at Kafka, right, in the messaging market, the number of deployments of Kafka will be very less. Only very large companies use it. So, but it's very popular in those large companies. You ask them to replace, they will never replace. Because what I have seen, right, that's because Kafka, there is no competition to Kafka. There is no UI. A lot of other things are there. You have to manage your cluster manually. UI is a big thing for anybody who is evaluating a product, right? There is no administration console. Because if you do the scalability and reliability comparison, you will not be able to find something that reaches the scale. Like millions of messages per second, Kafka has been tested with. So LinkedIn and all is doing billions per day.
No, my question was architecture-wise, what are the significant differences between Kafka and Flume that could essentially impact my decision to choose this product?
So Flume is basically a log file reader, and Flume is actually agent-based architecture. Kafka is just one part of the source and sink, right? Flume has a source where all the agent reads it and then syncs somewhere. So Kafka is actually the source, then Flume, the actual server, and the agent, sink, which actually pushes it to. So Flume pulls from somewhere, saves it in memory or disk, and then pushes it. So you just remove source and sink. Architecturally, Kafka is only the central part of it. It doesn't pull anywhere, and it doesn't push anywhere, because that is the job of the producer and consumer. And then Flume is actually specifically for log files, right? You specifically designed for log files. Actually, not exactly. You can do sockets and telnet and all that, but primarily it's designed for log files. And I don't know if you have because it's not a log. The key thing about this, I mentioned about the topics, right? The topics are the core scalability aspects. So Flume will not be able to handle millions of messages per second, even if you have a 50-node instance. So the scalability of Flume and Kafka cannot be compared. It's a huge difference. So if you have use cases where you have millions of messages, if you have maybe thousands, Flume will work. If it is millions, then you have to use something like Kafka or some RabbitMQ or something like that. So that is the primary thing. So that is not negotiable. Like you try with millions of messages, your Flume system will not scale at all. So there may be other factors also, like the consumer API and Zookeeper cluster and some other that related to this, right? So how to use? The other point is, see, when you have a logic where like you want to read one by one messages, right? You want to read message by message. You can do that with Kafka, but most probably you don't want to use Kafka in those scenarios because the latency, that means per message processing time will be less, but your scalability may not be high. Because scalability comes by reading 1,000 messages and processing it in one step, right? Because for each message you want to, each one thread will be blocked. So without that one thread, you can't process that message. So one thread will take the message, process it, another the same next message has to wait. Or if you want to do parallel processing, you have to 10 threads. 10 threads in parallel will read 10. But you can't have 1,000 threads in your architecture, no? Or in your JVM, reading 1,000 messages. So if you want scalability, no, then you have to think about this batch processing or no, where you can read 10 messages at a time. normal messaging engine, that's why you read one latest message only. So that relates to the next thing, that Spark streaming that we're going to start. I'm kind of out of time. Okay. So maybe some more questions will come in the Spark streaming. Let me just start here. Okay. Anyway, not many slides. Spark streaming is obviously based on Spark. But if you want to do streaming processing, that means you have this continuous messages coming and you want to process it in real time. So wherever you have this real time scenarios, you use Spark streaming. And so if you take a lens and look at the architecture of Spark streaming, it is not exactly real time. I told about this one by one messaging, right? So it does actually not a single message at a time, Spark streaming. It takes a batch of messages. But it doesn't say give me 10 messages or give me next 10 messages. What it says is, okay, I'll wait this window 1 second or 2 seconds. In Spark streaming you say, okay, this is my window. So whatever messages comes in that, I'll batch it together. And then it is very suited for the Spark API, MapReduce kind of API where give me all these messages, perform all this group by or map all these functions, all this data set, or reduce all this data sets into an aggregated point. That what you're doing in MapReduce is a lot of data items performing the same function on the same data, on the set of data. So that's where this batch is very well suited. So the word, I use micro batch, that is the industry terminology, but what Spark streaming uses is the word discretized streams. Set of streams, so stream 1, stream 2, stream 3. Each set of discretized streams. So in the API, in the code you will see you create a discrete stream. Create this stream. So then the other concept you have to know is Spark streaming needs at least 2 threads. One is for receiving your messages, the other is for processing your messages. So when you program in Spark, especially in the local mode and developer mode, you say locals, 1, all that. So it will create only one thread. So this is a problem for streaming architecture when you're doing development especially. Because in production you don't do with one thread and you have many threads. You will see that, okay, I'm receiving messages but no processing is happening. So by default you would have given one thread for the processing engine. So there's one receiving thread at least, okay, and you at least one processing thread. You can have many of them to do parallel processing. The other point is, with Spark streaming, if you're instead of using Storm or something, you can have all access to all the Spark platform API, the graph library, machine learning library, all SDFS API and everything. So that is another advantage of using Spark streaming. Micro batches, I'll look at the API. So Spark streaming, so when you use Spark, right, you need to receive real-time data, right? So they come with a lot of adapters. So all these adapters are called receivers. The terminology uses receivers. So they have ready-made receivers for Kafka, Flume. Kinesis is Amazon's equivalent of Kafka. It runs only on. Then they have ready-made Twitter connectors. Even socket, TCP sockets you can send. Then something called 0MQ. So 0MQ is like another messaging engine compared to Kafka. So the new concept here is the time window API. You are deciding on, so it's not that your function is just randomly called. Whenever your code gets called, right, you group by or map or something, it's working on a set of data and for this time set. And then your code has to finish within that time. Otherwise, next batch has come. So you cannot, your function, your application cannot delay too much because future batches keep coming. So suppose you said my time window is 1 second. Every 1 second new batches will keep coming. That will backlog and your Spark engine will get killed. Because what's happening is once you process, then you don't have to store this in memory. So Spark will actually throw away this data after you process it. Then that memory is cleaned up. So there are 2 advantages to that. You can have any number of data coming in. So you don't, if you want to process 1 billion messages, you don't have to have memory for 1 billion messages. Because in 1 second, how much messages are you processing? Only that much memory you need at a time. So that is architecturally important. Like Spark, if you want to query Spark SQL with 10 million messages, then if you don't have enough memory, because you need to query all those rows, then it will either serialize to disk or you will be slower. So that is in streaming, only that window is stored. Once you've done, you can throw it away and next window comes. So memory scalability is very good. The other point is, it's also a bad thing if your current program is slow. So you have 1 second of data and you take more than 1 second. Then the other guy who's coming in the sequence is slowed. Next batch is delayed. So it's queuing up. So then you take 1 second of data and you take 10 seconds to process them. So 10 batches are backlogged. Then you may get killed, you get out of memory. So maybe 10 is okay. You have what about if it's 100 or 1000 or something like that. And you have many threads in parallel like this, then processing threads are happening. So these are the things you have to think about when you're creating your architecture. So I'll talk about the receiver. So what I talk now is the receiver API, right? So what used to happen is the earlier versions of Spark, you have many workers. There's a master and many workers. So when you receive, what would happen is the receiver would be only one worker. All the data, like from Kafka and all, will go to one worker and then it has to be distributed to other workers. So that was the architectural problem, right? You don't want to copy to one place and copy again to other workers. You want to do parallel processing. No? Parallel processing is possible, but initial data comes to one worker. Then you do map partitions or something, use Spark API and distribute the load to all workers. So what they've done is since 1.3 of Spark, they've created a direct API. So that refers to that earlier question. What they've done is like for Kafka, they've created, I don't know for all the others they've created, but Kafka there is a direct API where you can, they actually, when you create a new discretized stream, each worker will read it directly from Kafka. Earlier that was not happening. Only one worker will read, and then you have to write some function there to distribute the load to other workers. So now we have parallel read happening with direct API. So nowadays, if you want highly scalable system, you should obviously, now it's 1.4, right? 1.4.1 is there. You should only use direct API. The other advantage is that they have created a next point, reliability thing. So what they have done is they have used the Zookeeper API to basically internally, instead of using the high level API, I said there is high level API and a simple API. Earlier they were using high level API, now they have used simple API, the Spark, and they actually stored offset information in Zookeeper and then they are retrieving it. The other point they have done is in direct API, in the direct API is that they have introduced this something called a reliability thing. So sometimes some architecture will say, I want to receive my message only once, right? But Kafka is, once you read it, Kafka has that message again. So maybe you read it, before processing it, your consumer crashed. Then it comes up again, it will read it again, because there is no track. So now Spark Streaming is supporting this exactly one reading with Kafka. So exactly one is available, not exactly one. Exactly once was available with only HDFS and any file-based system. So at least once is there. Exactly once is also available with Kafka. Now at least one with receivers means they have said with any kind of receivers. So what they have done is they store the data. So when you read from Spark Streaming, you can say store into RDD and then that can be persisted. But information of how much you have processed is not available. So now with the direct API, they actually store, how much you have processed also. It actually is stored in the local HDFS system. So that means you can actually say, when it's checkpointed, it will actually store into the system, and then the consumer was while processing it crashed maybe, like I said earlier. But when restart, it knows where it was the last time. So it will not reread messages from Kafka. So that is at least one is there. So this architecture gives you at least once, and exactly once is also possible. So is that? I think yeah. This is like a done. Next is references.
I have one question regarding the persistence. Is it an option or?
Yeah, it is optional. Yeah. Pointing, there's a checkpointing API function which you don't have to use if you don't want.
What exactly one at least once? How do you configure that?
So at least once is like the default thing. So exactly once you have to use the checkpointing API. So it's not a configuration point. It's the API, how you code it, how you code the receiver. So when you're reading from STFS and all, it's already there. You know? The Kafka consumer, the receiver API, will take care of. Kafka.
Let's say there is from Kafka. We are just processing it.
Okay.
What do you should write intelligent code to.
Yeah, in your code you have to write the checkpoint, basically checkpoint function. So every batch it will checkpoint.
So checkpoint you're saying it's like acknowledgement?
No, checkpoint is store this in metadata into disk. Metadata is not just offset, many other things are there into disk. So there are in Spark there's something called some other checkpoint, actually the same concept. Basically you want all your RDDs, right? So basically if it's flowing out of memory it will store to disk. But you can also say checkpoint of your processing information. So even without Spark streaming, the Spark API has a checkpointing function. It's the same concept here. So you can say, okay, this is the things I've processed, but that actually is to save your actual data to disk. Here metadata is saved to disk.
But will that have any internal performance? Because
Yeah, obviously, but it's not as much as saying all the data. It is the metadata that is saved, and it's not. You can configure that checkpointing window. How much, like I want to do every, some 10 batches or something like that. So it's a trade-off. If you do too wide, then you may repeat that window.
Depends on how much you're processing over
Yeah. Yeah.
But
But I don't think checkpoint is a huge overhead because it's just the metadata part that you're saving, not the actual complete data. Because your data is anyway there in Kafka, so you can read it if you want. Data is not lost. But if you're doing a 10 the core point concept of checkpointing in Spark itself without streaming is that you have a huge graph of data. You get the read map, reduce, filter and all that. Suddenly the engine went down. The complete thing is lost, right? So what you do is checkpoint in between. Okay, if you checkpoint, then that data is stored in disk. So when you restart, you just start from that point only. Huge tree you don't have to redo. Okay, the other point I want to mention is this here. When you are doing Kafka, right? There's this link which I have provided here. Okay, this is what I want to show in the code, but I have not shown it. So one point is very high chance that any demo will fail because Zookeeper or some delay will happen. Then you have to restart the thing. So you should look at this link, and when you have not done Kafka yet, this is the code thing you will refer to many times. This link is many times, but that quick start link is something you will have to do many times. Sometimes suddenly, your messages you are sending is not reaching anywhere. It's dead. So most probably it means that Zookeeper has assumed that your broker is dead or your client is dead because of some timeout issues on the network. So what you do is just download the code here. You just you can download the Kafka thing, and then you start the Zookeeper. So basically, Zookeeper has to be there before Kafka server starts. This is the Kafka server starting. Then create a topic is optional because only in development you create a topic. You see that, no? So you have to, when you create a topic, you have to give the Zookeeper URL. Replication factor, like I mentioned, replication factor. Number of partitions and this topic name. So I mentioned replication factor 1 and one partition. This is here. Oh, and then here you are actually listing. List all your topic details. It will print all the details of your topic. And there's another.
How do you send a file? I have seen this command line also, but
Yeah.
how do you send a file? What do you have to do?
Send a file. There is no file send option. It's a message. So
Yeah.
you can use some Java API to read the file, convert that to a message, and send. Save it as an argument. Send it as an. So this command line which doesn't mean that you have to use it like this.
Correct.
This .sh file actually internally calls a Java class.
For example, in log stash, right? What you do if you use log stash,
Yeah.
what you do is you provide the path to the log file, right? Maybe whatever the path is star.log,
Yeah.
for example, and when you start the log stash, it like picks up everything and it puts it in Elasticsearch.
Yeah.
Okay. When you're doing the ELK scan.
Yeah.
So does it do something similar here?
Yeah. So
Can you provide the path
see,
to
I
the
think
log?
that concept of there is no picker here.
Correct.
The middle guy is there. So you have to write your own guy who picks and source thing, no? The Flume source or the picking logic you have to do. Read from somewhere Kafka or something. No? Or this is and then you want to put it in the HDFS, right? The picking logic you have to write.
Okay.
Log file or something, then put it into messages. That is it. Any other question? So basically, this link I am going through because this you will need many times. So because if you are trying with Spark streaming directly, many other things can go wrong. It's very difficult to debug. So if you have a parallel setup with the Kafka, then you can test with the same zookeeper and the topics and see if it is working. If it is working there, then you can look at Spark streaming some other issue. That's it.